Okay, we're going to do Unit 7, Section 5A, rationalize the denominator. Just like giving me something like 2 over 4 doesn't look correct, having a radical in the denominator cannot be left. It needs to be simplified. So the big key here is that a radical square root cannot be left in the denominator. So that's our key here. Okay, and we're going to have to do everything that we've learned up to this point that has to do with radicals, which is simplifying and adding, subtracting, whatever you need to do. So you need to leave it in simplified radical form. I don't want decimals. That's not what we're doing at all this chapter. Okay, so the easiest way to explain this is just to do a bunch of examples with you. So that's what we're going to do. All right, so number 1, if you were giving the square root of 10 over the square root of 3, that cannot be left that way. It has to be changed, and we have to get that radical out of the denominator. Now, we talked about this in terms of a jailbreak as far as the radicals. So I'm going to talk about this as we're orchestrating a jailbreak. We need to get that root 3 out. Well, what do we need to get rid of a root 3? How can it escape? So what we've learned is the only way for it to escape is if there's another 3 there. And it has to be under the square root. It can't just be on the outside because that's different than inside the radical. So what we actually need is we need to bring a square root of 3 into play here. So we're going to say I need to orchestrate a jailbreak, or I need to get that 3 out from under the radical. In order to do that, I need another root 3. You legally can do that as long as whatever you do to the denominator, you do to the numerator. Because I want you to stop and think. What does the square root of 3 over the square root of 3 equal? And if you can't answer that question, what does 5 over 5 equal? What does 4 over 4 equal? They all equal 1. So we're not changing the value here. We're simply multiplying by a specialized 1. And this specialized 1 will allow us to get that 3 out from under the radical. So then what we do is we multiply top times top, bottom times bottom, because that's the rules of fractions. Now I'm going to do longhand for the first couple problems. I'm going to show every single step. So remember the rules of multiplying. You got to know the rules of multiplying fractions, and you need to know the rules of multiplying radicals. So multiplying radicals, remember, inside times inside, outside times outside. In the numerator, we have a 1 root 10 and a 1 root 3. So 1 times 1 is 1. We don't have to write that. And then the 10 and the 3, I'm actually going to write out in prime factorization. So 10 can be written as 2 times 5. And 3 can be written, let's do it this way. Let me color code it. So the 10, instead of writing a 10, I'm going to write 2 times 5 because I want to see if there's anything that can come out of this. And then the 3. Okay, so we're putting them all under the same radical. In the denominator, we have our 3 from our original problem, and then that 3 that we brought into the problem, the root 3. Now let's see what can come out. In the numerator, we have a square root of 2, 5, and 3. So there's no jailbreak that can occur there, and so nothing can come out. So 2 times 5 times 3 stays under the root and is the square root of 30. However, the whole point of doing this was to get the 3 out from under the radical, and that's exactly what we can do now. Because we have a pair of 3s, they can escape, something horrible happens, and only one of them makes it out. And so my simplified answer here is root 30 over 3. Okay, so that's what we're going to do to simplify each problem. All right, number 2 is the square root of 7x over the square root of 8. Now there's a couple ways to do this problem, but I generally like to orchestrate. If I have a square root in the denominator, I try to take care of that first. So the first thing I need to figure out is who needs to jailbreak. The square root of 7x is perfectly fine. You're allowed to have a radical in the numerator. You just can't in the denominator. It's the rules they came up with. So we need to orchestrate a jailbreak for that 8. And so in order to do that, we need another 8 in the square root. So I put a square root of 8, but I can't just put it in the numerator because that changes my problem. The only way to make this a legal algebraic move is also to multiply the numerator by the square root of 8. Okay? Now what I'm going to do in the numerator is I'm going to combine those two, just like I did before, outside times outside, inside times inside, and inside I have 7, which is already prime, x, which is already prime, and then 8, which can be factored out to 2 times 2 times 2. So I just prime factored the 8. That's where the pink 2's came from. In the bottom, I have the square root of 8, and I'm not going to prime factor the denominator because I already know I created a situation in which the 8's can come out. Okay, you could prime factor it, you get the same answer. Okay, so let's look at our numerator. What can come out? The numerator radical. Well, I have a set of 2's that can come out. So the 2's out front, and then I have the 7 and the x and the 2 still left, and so that gives me 14x still left under the radical. In the denominator, we orchestrated that 8 to come out, so now we have an 8 on the outside. Now we're not done here because this is also a fraction. It can be written as 2/8 root 14x. Well, what can 2/8 become? 2/8 become 1/4. So really this is 1/4 root 14x, or you could just go root 14x over 4. Now remember, the 14 is under the radical and the 4 is not. Therefore, they cannot cancel. We can't divide them both by 2. They're two different numbers, okay? We don't know that the square root of 14x is even. We don't know what that's divisible by. So this is our simplified answer. If you leave it as 2 root 14x over 8, you will lose a point because you didn't simplify it all the way. So you need to be careful and make sure you can simplify it all the way. Okay, let's try another one. Where I think I have 6 of them that I want to do. Number 3, root 2 over root 6. Again, not happy. That root 6 cannot be in the denominator. So I need to orchestrate a jailbreak. It's all legal as long as I do the denominator and the numerator multiplying by the same exact value, and that value is root 6. So in the numerator, we now have the 2, and then 6, which I'm going to prime factor to 2 times 3. In the denominator, we have a 6 times 6, and we already knew that was there. Okay? In the numerator, we can take out of 2, and 3 is left behind. In the denominator, we can take out a 6. Again, 2/6 can be simplified to 1/3, and then root x, or root 3, sorry. You could also write it as root 3 over 3. Okay? This is my final simplified answer. Again, just because this 3 is on the outside and there's a root 3 on the inside, these are two different values. They cannot be simplified. Let's try another one. Number 4. This one looks a little different. It's not any different. Root 3/10 can simply be written as root 3 over root 10. So pause it now that I've explained it to you and see if you can come up with the right completely simplified expression here. So what do we need to get out? The 10. So we have to multiply root 10 in the bottom. Can't just do root 10 in the bottom. You got to also do it in the top. So now on the top we have a root 3 and 10, which can be simplified to 2 times 5. In the denominator, we have a root 10 times root 10. Numerator, nothing can come out, so that's just root 30. Denominator, 10 comes out. Again, the 30 and 10 cannot cancel out. One's underneath a radical that changes it completely. So this is my simplified answer, root 30 over 10. Let's try another one. Number 5. Number 5 is root 27 over root p squared. Now this one, you may notice immediately that I don't really need to orchestrate a jailbreak because in the denominator, we already have p times p. It can already escape. In the numerator, we have 3 times 3 times 3. Let's say you didn't notice that and you still brought in a square root of p squared on the top and bottom. You'd still get the same answer. You just go through a lot more steps. So in the numerator, we'd get 3 root 3. In the denominator, we'd get a p. Nothing can cancel, and so that's my final answer. Okay, let's do one more. This one's a little more complicated, not much. Let's see. We have a root 3/5 times a root 6/4. 6/4. Okay, well, let's first put them together. So really what we have is root 3 times 6, which can become 2 times 3. And we have a root 5 times 4, which is 2 times 2. So all I did was prime factor those that could be prime factored. So in the numerator, a 3 can come out, a 2 is left behind. In the denominator, a 2 can come out and a 5 is left behind, but we cannot leave the answer this way. Think about why that is. What needs to be let escape from the square root? The root 5 cannot be in a radical, so we have to multiply the numerator and the denominator by a root 5. So what do we have? Now remember, when we're multiplying, outside times outside. So in case you need to write it, there's invisible ones in front of these. We just haven't been writing them because we've just been multiplying one by one. In the numerator, though, then, we have 3 times 1, which is 3, and then a 2 times 5 on the inside of the radical. In the denominator, we have a 2, and inside we have a 5 times 5. In the denominator, nothing can escape, so it's 3 root 10. In the numerator, we have 3 root 10. In the denominator, the 5's can escape. The 2's waiting on the outside. They get multiplied together. And this is 3 root 10 over 10. Now, don't let this fool you. I know it looks like that root 10 and that 10 can cancel. They cannot. Root 10 is not the same number as 10, and you can't just pull it out of there. Okay? If you put root 10 into your calculator, you're going to get a very weird decimal that can't just simply cross out with a 10. So you have to be careful with that. All right, so I want you to try the homework. If you're having trouble with it, you need to visit me in my Google Meet or get a hold of me and we can set up a time. And do your best. You don't have to you can do odds or evens on the homework and see how that comes out for you.